Scientists have just identified the formation processes of some of the universe's earliest galaxies in the turbulent era of the cosmic dawn. James Webb Space Telescope observations of the early universe around 13.3 to 13.4 billion years ago, just a few 100 million years after the Big Bang, have revealed telltale signs of gas reservoirs being actively slurped into three newly forming and growing galaxies. You could say that these are the first direct images of galaxy formation that we've ever seen, says astrophysicist Casper Elm Heinz from the Niels Bohr Institute in Denmark, who led the research. Whereas the James Webb Space Telescope has previously shown us early galaxies at later stages of evolution, here we witness their very birth, and thus the construction of the first star systems in the universe. Known as the cosmic dawn, the first billion or so years after the Big Bang is shrouded in two things: mystery and the fog of neutral hydrogen that permeated the universe and prevented light from propagating freely. The former, in fact, is the natural and direct consequence of the latter, since light is the tool we use to understand the universe. James Webb Space Telescope was designed, in part, as an attempt to penetrate this fog, since the infrared wavelengths in which it views the cosmos penetrate more readily and travel farther than other wavelengths. What we want to know is how everything came together. How, from a hot primordial plasma soup, the first stars and galaxies came together. The fog cleared under the light of early objects, and the universe took its baby steps towards what it is today. So Heinz and his international team used James Webb Space Telescope powerful infrared eye to peer towards the cosmic dawn, where they detected a signal traced to three galaxies. Specifically, the signal emanated from the neutral hydrogen surrounding them as the gas absorbed and re-emitted the galaxy's light. These galaxies, the researchers found, existed around 400 to 600 million years after the Big Bang, which took place around 13.8 billion years ago. This makes the three galaxies some of the earliest detected. These galaxies are like sparkling islands in a sea of otherwise neutral, opaque gas, Heinz says. Moreover, the researchers were able to distinguish the gas reservoirs around the galaxies from the intergalactic neutral gas. These reservoirs were determined to be quite large, covering quite a large proportion of each galaxy, suggesting that they were actively forming intergalactic material. And the fact that there was so much of this gas also suggests that, at the time of the observations, the galaxies had yet to form most of their stars. During the few 100 million years after the Big Bang, the first stars formed, before stars and gas began to coalesce into galaxies, says cosmologist and astrophysicist Darach Watson of the Niels Bohr Institute. This is the process that we see the beginning of in our observations. We still have a lot of questions about the cosmic dawn. We've barely scratched the surface, and there still lie many secrets wrapped in neutral hydrogen, many of which are yet to be discovered. But the three galaxies discovered by Heinz and his team is a step forward. Now that we know the galaxies are there, we can look at them more closely to better understand the galaxy formation process. One of the most fundamental questions that we humans have always asked is, where do we come from? Says astronomer Gabriel Brammer of the Niels Bohr Institute. Here, we piece together a bit more of the answer by shedding light on the moment that some of the universe's first structures were created. It is a process that we'll investigate further, until hopefully we are able to fit even more pieces of the puzzle together.